Hey boys and girls, here we go. We're going to start a new unit, Unit 2, and this is actually going to be solving quadratics. Unlike the previous videos I've sent out that said solving, they were actually just simplifying. Now we're actually going to be dealing with solving quadratics, and we have to first start to learn how to factor them, and then we're going to talk about how we set them up into equations, solve for them. So basically at the end of the day, we're solving for x. Eventually we'll have to start graphing these, and to be able to graph them, we have to know the solution. So it's going to get more and more complicated, but one of the most difficult things to do when you first start off in Algebra 2 is really learn how to factor and factor effectively, because there's going to be quite a few different formats you're going to see as we move forward. So we're just going to start off with the first one, which is 2.01, the notes. We're talking about trinomials, which are going to be 3 terms. This is the quadratic form, which is technically the quadratic equation, okay? Which equation is set equal to 0, which is ax squared plus bx plus c. From here, one of these days, if we ever get you guys in class, I'm going to show you how you break this down and you end up with the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll show you how you go from this equation to that formula, which allows you to solve for any quadratic. The quadratic formula will solve every quadratic. But so we don't have to use that big long formula. We're going to learn some steps and some basically techniques that would allow us to kind of break them down a little bit easier. The one method is called the star method, which is you can use for most of them and predominantly is the most widely used. We're going to talk about that. Additionally, we're going to talk about something called bottoms up, which is something that I've used for quite a while now, and you can use it for every one of them, but you technically only use it when your a, this number in front of your x squared, is greater than 1. And we're going to talk about that as we get a little bit further down into this. Also, one of the things you have to make sure that you look for are called GCFs. If something has a GCF, if something can be taken out or simplified first, always do that before you start with the factoring process. So again, solving quadratics, we're mainly dealing with trinomials here. The star method, we're going to talk about this. This is, right here, will be your value for your C. And what you're looking for, the value for your C, is you're looking for factors, if you will, factors where you're going to come here. This will be your B. This is the value of B, or your number, and this is the number. And here are your values, right there, that you're going to find that are factors of C, and additionally, they will combine to make B. That sounds really odd right now. If I show you one, it seems a little bit more straightforward. But to make sure we're looking for, this is my value of C, this is my value or my number of B, and that number also includes the sign. So it includes the sign of B. Let's just do one, and let's just go from there. So if we look at over here, we have x squared plus 3x plus 2. So our values are a equals 1, B equals 3, and C equals 2. It may benefit you to write this down like this, particularly in the beginning, to kind of help you, at least for the example. Okay, so we're going to work on our little star method here, okay? So let me get a different color so we can work through this. What that says is we put C up top. Our C is 2. We put B down below is 3. So what these two numbers here, what we're trying to find for these two values here, or we're looking for values that are factors of C, or 2, that can combine to make B. Well, the only factors of 2 are 1 and 2. And by the way, one thing I did forget is you need to understand that 2 is positive and 3 is positive, right? 2 is positive, taking the sign. 3 is positive, taking the sign. It's very valuable information when you do that. It seems a little cluttered, and when you get better at this, you might not have to, but if it's positive, if it's negative, it's a must. If it's positive, a lot of times we just understand that it's positive, we don't deal with it. When it's a negative, it's a must. And I'll show you what I'm talking about. I'll do one like that. So what we're looking at here is I got factors of 2, which is 1 and 2, and can 1 and 2 combine in any way to make positive 3? Absolutely, but they'd have to be plus. Positive 1 times positive 2 gives me positive 2. Positive 1 plus positive 2 combines to give me positive 3. So those are my factors, or my numbers, if you will, that are both factors of 2 that combine to give me 3. From there, you simply plug in your x values. So you're going to have this plus or minus here, which is x and x. And from there, you simply plug in your value. Plus 1, plus 2. So at the end of the day, this is your factorization of that trinomial. You factored it out. We've seen this, and we've used FOIL or Punnett squares to get to this, or for difference of perfect squares and stuff like that. Now it's a little bit different. They're going to be trinomials, and we go from there. So let's just do another one. First things first, you always got to ask yourself GCF, okay? GCF, question. Is there a GCF? No, 2, 15, this is 1 in front of this. There's no GCF. Also, you have to ask yourself, is A equal to 1? If A is equal to 1, you can just simply repeat this method. So for instance, A is equal to 1. So I'm going to use my C on top, which my C is negative 15. See how that's important to write that negative there. Otherwise, if you just write 15, it changes everything. My B is on bottom, negative 2. Again, has to put that negative in there. Now I need factors of 15. To do factors of 15, I got 1 and 15, 3 and 5. Those are all my factors. Is there any combination of either one of those sets of factors that could combine in some way to give me 2? Yes, 5 and 3. So here's the trick. How can I combine 5 and 3 and get it to equal negative 2? Well, if I had negative 5 plus 3 gives me negative 2. From there, I have negative 5 times positive 3 gives me negative 15. Negative 5 plus 3 gives me negative 2. So I found 2 factors that multiply to give me C, and 2 factors that add together to give me B. Now I can just plug them within my little formula, which is x minus 5, x plus 3. And these are your factors. You write that on the line. Not a lot else to do there. That's it. Next one, let's do number 2. Very similar but different. Now I have instead of having a negative and a negative, I have a negative and positive. Same methods though. We're going to go our star method. We got positive 12, negative 7. Takes a little bit of time. Make sure you get these things right. If you don't put your B on top and your C on bottom, it doesn't matter as long as you understand that you have to have factors of C that combine to make B. It's not top and bottom. Wherever you put them is okay with me, but you got to keep it straight exactly what you're looking for, whether it's factors of 12, factors of 7. Do they combine to make 12 or do they combine to make 7? I need factors of 12. With factors of 12 are 1 times 12, 2 times 6, 3 times 4. Are there any 1 and 12? No way it's going to give me my 7. 2 and 6, can't combine that in any way to give me 7. 3 and 4, absolutely. So I got 3 and I have 4. Doesn't matter which side you put them on. You can put 4 on this side, 3 on the other side. Doesn't matter. So the question now is, I need 3 and 4 to multiply together to give me positive 12. Well, 3 times 4 gives me 12. However, does 3 plus 4 give me negative 7? It does not. So I'm going to have to manipulate a little bit here. What if I had negative and negative? So negative 3 times negative 4, negative times a negative gives me positive 12. That works. Negative 3 minus 4 is negative 7 as well. That works. We simply put it within our format. Once we find our 2 factors, and there she goes. Those are our factorizations of them. Not overly complicated there, but keeping that stuff straight is vital. I know this is a little bit low, but I want to leave that up there for now, just for now, because I want to show you a little. Actually, you know what? I'm gonna erase that. That's pretty straightforward, at least in my opinion. I know some of you guys have seen maybe some factoring before, but I want to show you, I believe 3, 4, 5, and 6 together instead of this. This should be pretty straightforward. If it isn't, you can always rewind the video and go back. Cleaning the board, like a nice clean white board as we move forward. All right, nice clean white board. We're going to try to get 3, 4, again, they're numbered 3, 4, 3, 4. That's fine. We're going to go at them like this, and we're going to make this a little bit smaller so I can kind of have things within the screen. Have everything within the screen. There we go. That's what I want. You guys should be able to see that at home. So again, first questions we always ask ourselves is GCF. Okay, so look at this. This looks crazy. It looks crazy. If you're sitting there like that ain't even close to what we had before. It looks crazy. So if you ask yourself the term GCF, question mark. Well, if I look at that, I can see that my 6 is a factor of 24 and 24. So quite possibly I could have a GCF of 6. If I have a GCF of 6, I pull that 6 out, that cancels, so I'm just left with x squared. This becomes negative 4, and then x, and this becomes positive 4. So I have the 6 out here as my GCF, but now I'm almost back to where I was before. This isn't overly complicated. We just did 2 of these. So now I'm going to have my little x. My C is positive 4. My B is negative 4. What are factors of 4? 1 times 4 and 2 times 2. 1 and 4. Can I make 4 with 1 and 4? I can't when I combine them. I either get 3 or 5. 2 and 2? Absolutely. Here's the trick. Again, we're going through this. Keeping this stuff straight is vital. While 2 times 2 is positive 4, 2 plus 2 can't give me negative 4. So I got to make these negative. Negative 2 times negative 2 is positive 4. Negative 2 times negative 2, or excuse me, negative 2 plus negative 2 is negative 4. Again, these signs within this x, vital. So now we did just what we did before. However, what have we left off? We cannot forget that 6. Please don't forget that 6. You could write it just like this on the line, or you could rewrite it as x minus 2 and squared, because that's what it is. X minus 2 squared. Recognizing that is pretty important, okay? So if we look at the other 4, we're looking here, and A is 1, that's great, but is there a GCF? Is there something I can pull out from all 3 of them? Absolutely. I have 3 x's there, 2 x's there, and 1 x there. It's not always a number that's a GCF. Sometimes you pull out that variable as well. So when I rewrite that, again, we're right back very close to how we've seen before. A is 1 and it's pretty straightforward. The one thing we just got to keep track of is that x. Okay? So it might benefit you to go ahead and write that. You know you're going to have something that looks like this when it's all said and done. Go ahead and write it over there to the side so you have it. So you don't have to worry about ever forgetting it. Okay? Let me move that piece. There we go. Don't ever have to worry about forgetting it. So now we have, that's not what I want to do. There we go. That's where I want to be. My x, positive 10, negative 7. What are factors of 10? Factors of 10 are 1 times 10 and 2 times 5. 1 and 10 in no way is going to give me 7, but 5 and 2 will. And again, it doesn't matter if I put 2 and 5 or 5 and 2. It's irrelevant. Again, we're back at the process of, oh, well, I need positive 10 on top, but I need the negative 7 on bottom, so these have to be negative. Sometimes you'll see, and we'll get to that, where 1's negative and 1 is positive. So far, they've added up, or they've combined in the sense that they both have to be negative. We're going to get to one of those where 1 has to be positive, 1 has to be negative, because that's when it gets a little bit tricky. From here, all we do is fill in our little boxes, and we're done. That's it. That's all she wrote. You want to write it on the line? That'd be awesome. Those are 3 factors. Now, when we start solving these, which will come tomorrow, I think it's tomorrow. Right now, we're just factoring. We actually might solve some today. I forget. If you notice, remember how I said the largest exponent always tells you how many solutions you're going to have? Well, that's 3 solutions. Hence, that'll be a solution, that'll be a solution, and that'll be a solution. We're going to work on that as we get to it. A little bit more to get to before we get there. Okay? Okay, number 3. This one's going to be a challenge for some of us. Is there a GCF? Well, 3 and 6 have something in common, but 3 doesn't have anything in common with 11, so there's no number GCF. 2 x's, 1 x, no x, so there's no variable GCF. So we're just where we're at right here. This is not something, and my A is greater than 1. When my A is greater than 1, even though my A was greater than 1 up here, I had a GCF. When I pulled the GCF out, my A is not greater than 1. Here, I don't have a GCF, and it's greater than 1, so I got some issues here I got to deal with. We're going to work on this thing called bottoms up. Crucial terminology. The first thing I always want to do is I want to make my A 1. If I make my A 1, I can just do this. What do I do? My little crisscross, my star method, and find that, and we go from there. So what I want to do in the bottoms up form, when I can't get my A, when I don't have an A of 1 and I don't have a GCF, I'm going to use this method where I'm going to take this A and I'm going to multiply my A times C. Okay? So this is going to be times 3. When I do that, I'm taking that 3 and I'm throwing it at the end of the train. Okay? It's back there for now. I'm making it look different. When I do that, all I have left is x squared minus 11x, but now I have 3 times 6. 3 times 6 is 18. Hey, if you look at this, now we're getting closer to what we talked about before, where our, here's our x squared minus 7x plus 10. I'm right here again. What do I do when I'm right here, when I have my a equal to 1? I simply use my little star method, and I have, that was positive 18. Some of you guys are probably yelling at the screen right now, but I'm sorry, it's positive 18. So I got positive 18, and I have negative 11. Right here, those are my numbers, right? Right there. Positive 18 is my C, and negative 11 is my B. So this is my C, and this is my B. A little bit stuff to keep straight. We're going to work on it, though. So I need factors of 18. Let me make sure you guys can see all this as I'm writing over here to the side. Yeah, you can see it. It's a little written a little small. You can make it larger. So I want factors of 18. 1 times 18, 2 times 9, 3 times 6. Should be it. So can 18 and 1 get me to 11? Negative. 3 and 6? No. 9 and 2 can, though. So if I go 9 and 2, they both have to be what? Negative. Negative 2 times negative 9 is positive 18. Negative 2 combined with negative 9 is negative 11. So here I go. So now I just do what I did before. X minus 2, x minus 9. Okay, so here's the concern. Remember this big old bad boy where we multiplied by 3 up here? We multiplied by 3? Well, anytime you do something, or anytime you change the way something looks, and you're not multiplying by 1, you have to do the inverse property of that to ensure that it looks the same afterwards. So I multiplied by 3, so now I'm going to come back around and I'm going to divide by 3. Now remember, I multiplied that c by 3, or that back number, so now I'm going to divide my back number by 3. Okay, multiply by 3 to change the look, divide by 3 to bring it back whole. Okay? Next step is simplification. Okay? Simplifying. So x, can I simplify 2 over 3? No. I cannot. Can I simplify 9 divided by 3? Absolutely. I can. There it is. Here is where the term bottoms up comes from. After I've multiplied by that a, or my 3 for this term, and then after I've divided by my 3 to bring it back to natural, or where it was, multiply by 3, divided by 3, I'm back to kind of the beginning phase. Unfortunately, I have this fraction. I can't leave that fraction. So we do this bottoms up method. If you have something that's on the bottom, it must come back up to the front. That is why it's called bottoms up. I took it from the front, I put it in the back to get rid of it for now, so that I could use this star method so that my a is equal to 1. My a was greater than 1. I can't use the star method when a is greater than 1. You can, but it's a little bit more confusing. So I put it in the back, come back around, I find my binomials, but since I put it in the back, now I gotta kind of take it out of the back. So I divided it out of the back. Something is left in the denominator, which means bottoms up. Now those are your 2 factors, okay? When you multiply these 2 binomials together, you will end up with the original trinomial. If you want to check, go ahead and check. Okay? So let's do the other 4. They're stacked on top of each other now. It's kind of kooky. All right. So is there a GCF? There is not. Is my A equal to 1? It is not. So I know I'm going to use bottoms up. I know I'm going to use bottoms up. Multiply that 5 times 4, x squared minus 8x minus 20. My a is equal to 0 again. Again, I multiplied by 5. It may be beneficial for you to write that. Multiply by 5. Because you know over here somewhere, you got to divide by 5. You're not quite sure where, but you're going to have to. In the process of this, we're going to use our little formula here, or our little star method, and we're going to go, all right, well, I got negative 20. This is my C. And negative 8. Negative, negative. It's going to be interesting. So I need factors of 20 that will combine to give me 8. Well, I have 1 times 20, 2 times 10. Hey, I don't really need any more. Once I get to one of them that's going to give me some form or another I can manipulate and make it 8. Like I can manipulate 2 and 10 to give me 8 or 12. One way or the other. So I'm just going to write that number there first, and then I'm going to determine my signs. Well, since 20 is negative, that means one of them has to be negative because it has to be a negative times a positive to give me a negative. The key is you can either remember that if the bottom's negative and the top's negative, the highest number has to be negative, because at the end of the day, negative 10 times 2 is negative 20. But I need a negative 8, which means the largest number has to be negative. Negative 10 plus 2 is negative 8. Little things that may take some time. Some of you guys may grasp it easier than others. Some may take a little bit of time. So here we go. Now we just plug in negative 10, positive 2. All right, we see it. It's sitting there. It's telling me, oh, don't forget, buddy, I got to divide these things by 5. I multiplied it by 5, so I got to divide them by 5 to make it even. In the process of that, the next one, which is very, very crucial, is simplification. And here's the drill. One's leveled out, one did not. Bottoms up. If you can follow this little format, instead of trying to guess and check constantly, you just constantly just roll through this, it'll be so much easier. And here's the thing, you can always, you can use bottoms up for all of them if you want to. I mean, at the end of the day, there's a 1 here. So if I multiply 1 times 10, still 10. So I'm doing the same thing. Then divide the 1 out. It's not going to change anything. So technically, you're using bottoms up either way. The only difference is here my number is not 1. If you want to look at it in that way. Okay? So that is factoring a trinomial. It's factoring trinomials with GCF, and it's factoring trinomials where a is greater than 1 using the combination of the star method and bottoms up. So the next things to do are to factor and solve. So here's a new step. So we're going to do the exact same thing we just did, with the exception now is it's saying, okay, you can factor, buddy, but can you solve? At the end of the day, the whole purpose is to solve. It is not to factor for the sake of factoring. It is to actually attain a solution. How do I know I want a solution? Number one, it'll say solve, but the biggest thing, it'll have an equal sign. It'll have an equal sign. So, the first thing you do when you do this is it has to be equal to 0. Whatever it is has to be equal to 0. So if I look at this, I have x squared minus 3x minus 4 equals 0. This is equal to 0. I can move forward. Is there a GCF? First question. No. Is a equal to 1? Yes. So we're going to use the star method, okay? Crisscross. My C goes on top, -4. My B goes on bottom, -3. What are factors of 4? 2 and 2 is not going to give me 3, but 4 and 1 will. 4 and 1 will give me 3, but unfortunately 3 is negative, and negative 4. 4 is negative on top. Both of these are negative. That means one of these has to be negative and one has to be positive. Since this is negative, the largest number, positive. Largest number is negative, then a positive. So I have negative 4 plus 1 is negative 3. Negative 4 times 1 is negative 4. Here's my factors. And here's the difference. Equals 0. Okay, so those are my factors. My factors are x minus 4 and x plus 1. When you factor things, the purpose of them setting them equal to 0 is you set each one equal to 0. So I say x minus 4 equals 0. That means x equals 4. X plus 1 equals 0. That means x equals negative 1. So my solutions are 4, comma, negative 1. X equals 4, comma, negative 1. What that means is this. If you plugged in the x value here, they'll be equal to 0. So 4. 4 squared, 16. Minus. 3 times 4 is 12. So 16 minus 12 is 4. 4 minus 4, 0. That's why it works. We're finding solutions that'll plug into there to make it equal to 0. Negative 1. Negative 1 squared is negative 1 times negative 1 is 1. Minus 3 times negative 1. Negative 3 times negative 1 is positive 3. So I have 1 plus 3 equals 4. 4 minus 4, 0. So they're both valid. The next one's a little bit different. Why is it different? Well, it's not equal to 0. If it's not equal to 0, you have to set it equal to 0. So I got to move some things. Here you want to write things in standard form, which basically means my squared to my x term to my constant. So you will rewrite this as 5x squared minus 22x plus 8, and then this equals 0. This cancels, okay? All right, is there GCF? No. Is A equal to 1? No, it's greater than 1. That means we're going to use the star and bottoms up methods. So to start, to use star, we got to make A equal to 1, so we're going to multiply by 5. We're going to end up with x squared minus 22x plus 40 equals 0. Wow, big number. But when we crisscross, positive 40, negative 22. Are there factors of 40 that can get me to 22? I'm not going to write them all out. At some point, you can do something for yourself. There is 20 times 2 gives me 40. Since 40 is positive, they can possibly be positive, but this is negative 22, which means they both have to be negative. Negative 20 times negative 2 is positive 40. Negative 20 plus negative 2 is negative 22. From there, we write our little factors. Equal to 0. What's the problem? Well, multiply by 2, multiply by 5, divide by 5. Simplifies out. Uh-oh. It did not. So what happens? Bottoms up. And you have x minus 4 and 5x minus 2 as my factors. Those are my factors. My solutions will be each of those factors set equal to 0. Add 4 to both sides, so x will equal 4. And 5x minus 2 equals 0, so 5x equals 2. That means x equals 5, x equals 2 over 5. 2 fifths, comma, 2 fifths. All right, guys, so that's how you're going to use and solve them. So we did the factoring. We did the factoring of a equal to 1. We did the factoring of a greater than 1. We used star, GCF, bottoms up. Now we're setting everything equal to 0 and solving for it. If you were to plug 2 fifths back into there, it would be equal. If you were to plug 4 back into there, it would all equal. And you always, anytime you plug stuff in, you always plug back into the original equation. Let's keep it moving. I don't know how many's left, but there seems like a whole heck of a lot. A whole heck of a lot left. Whole heck of a lot. All right. Let's see. Oh, they got an application problem too. That should be interesting. Okay, so I'm going to shortcut a few of these. At some point, you need to start to grasp it. I can't show every step. So you have to, since this is not equal to 0, you got to add 2 to both sides. When I add 2, 2x. That's what I'm going to end up with. I add 2x to both sides. That cancels out and equals to 0. I'm going to use the star method. Factors of 48, 8 and 6. 8 and 6, 8 times 6. Is there a way that I can multiply these and get well, yeah. This could be positive 8 and negative 6. Gives me negative 48. Positive 8 minus 6 gives me positive 2. A was equal to 1. We didn't use bottoms up. Is there anything left to do? No, not for my factors. There's my factors. There they are. Sometimes it gets confusing. Am I done? That was easy. Well, now you got to set these equal to 0. Each individual 1. Move them over. I'm not showing that, that plus 6 or minus 8 kind of step. At some point, you guys have to be have that ability. And those are your solutions. 8 over there, that's going to be a little bit of a challenge. So let's get after it. First off, there is no GCF. 9 and 18 have something in common, but not with 5. However, when you're looking at it, you know you're going to, no GCF, A is greater than 1, so I'm going to use star and bottoms up. I'm going to multiply that. X squared minus 18x plus 45. 9 times 5 is 45. 0. Star method. Plus 45 minus 18. It's a little tricky here. What factors of 45? Well, I know what they are, and you guys got to work on your factors. It's going to be 15 and 3. And because this is negative and this is positive, they're both going to be negative. So now I have factors that are x minus 15, x minus 3, and it's equal to 0. See this loop I do up here? That loop a lot of times tells me to not forget I got another loop. So this is 9 and 9. Here's where this gets tricky, and I'm glad this problem is here, okay? Divide by 9, by the way. Okay. All the other ones, they've simplified out to a whole number or something. And some of them did and didn't, and fractions didn't. You still have to simplify here, okay? When I say the word simplify, I mean simplify. So for instance, when I simplify this, 15 divided by 9, are 15 and 9 are both divisible by 3, so it can be 5 over 3. 5 over 3. There are 3 times 5 is 15 and 3 times 3 is 9. 5 over 3, okay? Kind of pull the thread. It's just simplifying a fraction. Calculators will do that for you as well. This one's a little bit easier. 3 over 9 is 1/3. Still equal to 0. What's going on, man? It didn't simplify. Well, not always, but still gonna bottoms up. Still gonna bottoms up. A little bit tricky. If you don't simplify that and you make that 9x minus 15 and 9x minus 3, it's all gonna be wrong. What's up? What you want, man? Somebody's looking in my window. So anyway, if you want to do that, then this is the deal. All right, so you have to keep track of this simplification. That's why I put it in red, highlight. It has to be simplified. If you don't simplify that, you're not going to get 3x minus 5 and 3x minus 1. At the end of the day, these first two terms, 3x times 3x, have to be equal to the original first term. If you made this 9x and this 9x, that would be 81x squared. Well, that's not 81x squared, that's 9x squared. So please make sure you keep track of that. Also, when you're here, okay, you have to make sure. You could do this the easy way and say, well, that's x equals 5 over 3. That's how it's solved. Or you could go to this original one, which you got to go, or the last one, and 3x equals 5 and x equals 5 over 3. A lot of times when you use that simplified version and you're dealing with fractions, then you can always just use the simplified version and actually see, hey, that's already a fraction, I just move that over, and that will be one of my solutions. In the process of doing that, you could use the same. So if I looked at this one, my solution should be x equal to 1/3. It should be 1/3. If I use this, I would have 3x minus 1 equals 0, 3x equals 1, x equals 1/3. So it doesn't matter. Some of these things, you're going to have to find a few shortcuts along the way. You don't have to, but it'll help you in the long run of making sure that you keep this stuff straight, if you will. All right, so we got one more application problem to do, and then that's going to be done for the day. I mean, this has turned into a long video. It's Friday, it's afternoon, I'm kind of tired, kind of out there. So just stay with me best you can, and let's do this application problem. All right, so it says a rectangle has the area of x squared plus 9x minus 36. So area we don't know what the area is, and to be honest with you, the area is totally irrelevant. It doesn't matter. Okay? What does matter is what they're asking you. Find two binomials that could represent the length and the width of the rectangle. What it's asking you for is to say, here's a width and length. What are they? They don't want a number, they want binomials. They don't want a number, they don't want a solution. Not yet. Okay, so if they don't want a number, they don't want a solution, what do? We do what we always do, and we factor. B and C, two factors. 12 and 3. Some form of 12 and 3 is going to give me 9. That's what you always got to look for. How could those two combine in some way to give me that B? Okay, I don't want to put 36 and 1, and I want 9 and 4. Well, that's not going to give me 9. Some of these things have to be kind of a little bit you got to get to. 9 is positive, so that's positive, that's negative. So positive 12 times negative 3, negative 36. Positive 12 minus 3, 9. Plug and chug. Is it asking you for a solution? No. What it's asking you for is what two binomials can give me that area. Area is length times width. this times this will give me that. And that's where we go, boys and girls, working on factorizations, working on solutions. For me, I would probably plug in something to make you figure out what actually the area is, but we'll get to that at a later date and time. Y'all have a good one. Good weekend. Bye-bye.